Now, what is this? This is a box of the tripod. But what you can consider this is to be a cube, a cuboid, not a cube, a cuboid to be exact. I am holding it from these edges. This is a, if you consider this is the base and this is the top, I am holding it from the base and the top, and I am holding it at the center. So here basically lies the axis. I am rotating it on its axis. So with respect to this imaginary line of axis, we are going to place the solid. Now let me take another object. Suppose I am taking a pyramid. The axis of the pyramid shall pass through the center of the base. You draw two triangles and you will get a center here. So the center of the base to the apex, it will pass something like this inside. इसके अंदर से ऐसा करके pass करेगा. Now if you can imagine the axis passing through the center from the apex to the center of the base, it is like this. Now if I have this HP and VP like this, I can define the object. I can define this solid with respect to its axis. That is, the pyramid's axis is perpendicular to HP in this position. In this position, the pyramid's axis is perpendicular to VP. Now, axis being a line, all the conditions of line are applicable in this case also. So, as we discussed in the last class, the axis of a solid cannot be perpendicular to both the plane at the same time. It cannot be. It can either be perpendicular to one and parallel to another. Even in this condition, this is perpendicular to VP and parallel to HP. It can be parallel to both the plane. You can hold it like this, and this will be parallel to both the plane, both HP and VP, the line, the axis. But it cannot be perpendicular to both. Now, first condition being the axis is parallel to both the, like if I take example of this one, in this condition if I keep it like this, the axis of this cuboid is parallel to both HP and to VP. And slowly what I can do, I can keep on inclining this. And now the axis of the solid is inclined to HP but parallel to VP. And this can go on until it becomes like this, where the axis of the cuboid is perpendicular to HP but parallel to VP. The same holds true when the condition is like, we take the base condition again, and we are saying that the axis of cuboid is parallel to HP and VP. But in this condition, if I go on inclining, this is now inclined to VP but parallel to HP. And similarly, it can go on inclining itself furthermore until and unless it gets perpendicular to VP but yet parallel to HP. So these are the three different conditions we have to assess. Parallel to both the plane, inclined perpendicular to one plane, parallel to the other, and third is inclined to one plane, parallel to the other. These three basic conditions we are going to assess through some examples. So we have a question. Draw the projection of a pentagonal pyramid, base 30 mm edge and axis 50 mm long, having its base on HP and an edge of the base parallel to VP. Also draw its side view. Now it is said this is a square base pyramid. Now here we are told it is a pentagonal pyramid. You can imagine this pyramid to be pentagonal. Doesn't matter much. The base 30 mm edge, like base edge, this edge of the base is 30 mm, it is said. Axis 50 mm long. Axis is the height of the pyramid. Okay, that is 50 mm long. Having its base on the HP, having its base on HP like this. Okay, like this, base on the HP. And now it is said one edge of the base is parallel to VP. One edge of the base is parallel to VP, somewhat like this. Now they have asked draw the projection of the object, and also they have asked draw its side view. Side view, how will you draw? Remember the concept of auxiliary plane. So we will take the auxiliary plane somewhere here. We will take the projection on this plane and we will open up the plane. And so you have the auxiliary plane lying here with the axis in between. This is the VP, here is the axis, and this is the HP. The image will come here, here and here. Here whatever you get is the side view or the side elevation. Now let us draw. So what you have is a pentagonal pyramid. So we write the condition: pentagonal pyramid, base how much? 30 mm side and axis 50 mm. One edge parallel to VP, base on HP. These are the conditions. So you have a pentagonal pyramid, one base and the axis side is किधर लास्ट होता है
इधर से
start. Do you have a pentagonal pyramid? Second condition, the sizes of the pyramid is given. Third condition, it is said base is on HP, and fourth condition, it is said one edge of the base is parallel to VP. Now if you draw it simply, let us make the XY first, X dash, this is VP, this is HP, and now we shall draw the pyramid. Now since the base is on HP, so we will first start with drawing the base of the pyramid. Now base, pentagon base, what will be the base of a pentagonal pyramid? It will be a regular pentagon. Now you can place the pentagon like this, but will it be okay? No. Why? Because you can place the pentagon to be like this, something like this, the base. But this won't be okay because it is said one edge is parallel to VP. So keeping one edge of the base parallel to VP, we draw the base on the HP. So one edge of the pyramid we will draw it parallel to VP, and then we go on drawing the pentagon first. Now this is the pentagonal base of the pyramid. But is the pyramid complete? No. Because you see here in the model, when you look at the pyramid from top, like pyramid is like this and you are looking from the top, what you can see these edges. In case of a pyramid, you can see the edges. Had it been a prism, you would not have seen the edge. But since it is a pyramid, you can see the edge. All are converging to the center. So you have to draw the edge of the pyramid. You can name the pyramid A, B, C, D, E, and this point we can name it as O. Now pentagonal, this base is satisfied, one edge is parallel is satisfied, this side it is given 30 mm, this is satisfied. Like one side you can take the measurement and it will be around 30 mm. Now you need to draw the elevation. We take projection from all these various points. Then this B will coincide with O. This will be collinear. This B will coincide with O. Now since it is resting on the HP, there will be no gap between the reference line and the object in elevation. Now take a height of how much? 50 mm from the reference line. Take a height of 50 mm from the reference line. It may be somewhere here. This is the axis. From the axis also you can take projection, which will be collinear with B. And you may take the projection, and this is where it intersects. This represents the height, the topmost point, the apex. Now you need to draw the various points. A, now you see, you are looking at the image from this side. This is the center. If you draw a straight line across the center, an imaginary straight line across the center, whatever is in front of this straight line, you can see. Whatever is behind the straight line is away from you and you cannot see.
Start.
Now what you need to do, all these points in front of this imaginary line you can see. Whatever is behind is on the back side, you cannot see. So this A will be represented with a firm line. A will be joining with O. This is point O. It will be firm line. B, this is again a firm line. This is C. This is a firm line. D and E are on the back side. They cannot be seen, though they are there. So what happens? You need to join O with D and O with E using thick dashed lines. Thick dashed lines. You take the things here, A dash, this is B dash, C dash, this is D dash, this is E dash. And you need to show the axis, which will be near to this line, nearly overlapping with this line. So this is the required projection. This is done. So if we continue with this, what happens? If I ask you that you draw projection of a cylinder or a cone, and I want you to draw this. Suppose there is a cone which is on the VP. It is perpendicular to the VP. The base of the cone is on VP. It will be like this. The base of the cone is on VP, perpendicular to VP, and then you need to draw this cone. So how will it come? If it is on VP, that means on what will you see on the VP? If it is on the VP like this and you are seeing it from the front what will you see? From the front you will probably see a circle with a center, this center, the apex point. And on the HP, what will you see? On the HP, you may see a triangle. So if I draw it here, what you may see? You may see a circle on the VP along with a point. That is the apex point. And what you may do for the elevation part, you can take projection from both the side and from the center as well. You will get some height here, and then you draw. How to know this is a circle? What you can do, this is a cone. You can divide this circle into 12 equal parts. And from each of these points, you can take projection. And you take projection in. And there will be an axis line. This is projection of a cone. Similarly, you can make one for cylinder also. You can have a circle drawn for the cylinder, and for the cylinder the plan in this case would be something like this. And then again these 12 equal points. So you can easily draw this 12 these lines, which will be like closing each other, close to each other like this. You can understand that there is a curve. One thing in discussion which I forgot here is you had to draw the side elevation. The side elevation will be here forgotten. Now for the side elevation part, let us complete it as fast. We have this one. Again, maybe y dash you can name it, and this is the third quadrant. So what now you need to do? You need to draw the side elevation. For the side elevation, first of all we take projection from the plan. Projection from the plan goes like this. E and D will be collinear and they will end up here. A and C will be collinear, they will come here. B will be here. At last you have another point, that is O. It will come somewhere here. Take a compass, locate it here, center it here, take the radius progressively, and you transfer these points here. Otherwise you can simply use a 45 set square, put the set square here, and you take the projection. Once these are following this line, you take it vertically now. Now how will you take it vertically? First we take point O, which defines the height. The point O, it is here. Now this point you take vertically first. From here you get the height. This is point O. Rest of the points just fall in place. You have E and D as collinear point. So D and E are collinear, so they will fall in the same line. So you can join this, because from here also if you see this half, you can see this and this line clearly. This and this would be invisible or at the back. So you have this joint. This is, you are looking from this side. So E will be before and D will be at the back. So this is E by D. Then this is the line of O. Then comes this one. A and C will be collinear. This will be A by C. And you can join it. This is basically point A by C. And this is B. It went up to here, and this is B. And you need to show the axis. This is the axis. Axis will fall along this line of O. So what at last you can do? You can darken these parts. Okay, so this question is done. It is clear. This is the plan, front elevation, side elevation, and projection of circular solids of revolution are also done here, like projection of a cone, projection of a cylinder. Now we can move up to the next point, next topic.